So in this video, we will talk about the dot product and the angle between two vectors. So now we're going to finally start multiplying two vectors together. So because we talked about scalar and a vector, and that gave me a vector, now what we're going to do is a special kind of product. So here, when we multiply two different vectors, there actually is two different types of multiplication of vectors. The first one is what we call dot product, and the other one is what we call cross product. And cross product, you'll talk about that in when you get into pre-calculus, and that deals more with three-dimensional vectors. But here we're only going to do the 2D case and talk about dot product. So here, what's going to happen is when we multiply the two vectors together, you're going to get a scalar. So you're going to get a number at the end. You're not going to get another vector. So this is what we call the dot product. So the dot product is very basic. Oh, I forgot an equal sign there. Okay, so the dot product of two vectors is just the sum of the product of the horizontal and the product of the vertical components. So if V is equal to AB and U is CD, then the dot product, so taking the dot, so multiplication of U and V, is going to be multiplying the A and C together and then adding the multiplication of B and D together. Okay, so in the end, you're going to end up getting a number. Okay. Um, so let's talk about another thing. So the angle between two vectors. So the angle between two vectors can be given to you as this formula. So basically, it's taking the dot product between the two vectors and dividing it by the multiplication of the magnitudes. Okay, so here we have something really special about the vectors. So if the dot product between the vectors is 0, okay, so if you take the dot product of two different vectors and you end up getting 0, we call the vectors orthogonal. Okay, so what orthogonal means is that they form a 90-degree angle. So that means the vector going this way and a vector going this way, and they're forming a 90-degree angle. So usually you would say that this is perpendicular, but when we talk about vectors, we call them orthogonal. Okay, so it just means that they are forming a 90-degree angle. So here, let's do a couple of an example. So given the vectors, u equals 3i minus 8j, and v equals negative 2i. Let's first start off by finding 5u minus 9v. So we're going to take 5 times u, which is going to be 3i, oops, not component, 3i minus 8j, minus 9 times negative 2i. So I'm going to multiply this together. So this is going to give me 15i minus 40j plus 18i. So here, let's just combine the like terms. So I'm going to just take this 15 and add it to 18, and you're going to get 33i minus 40j. So this is basically the vector 33 on the x direction, negative 40 on the y direction. Now what you want to do is to find the dot product. Okay, so the dot product is going to be the multiplication, or 3i minus 8j dotted with negative 2i. Okay, so you're going to take the dot product of this. So you're going to take the components of the x values. Okay, so it's going to be 3 and 2. So that's going to be 3 times negative 2. And you're going to add it to the y's. So it's going to be negative 8. And then there's no j component, so that's just going to be 0. So this goes away, so you're only left with negative 6. Okay. Then you want to find the angle between the two vectors. So the angle between the vectors is the cosine of theta is equal to the dot product between the two vectors divided by the magnitude of the two vectors. Okay, so we just took the dot product between those two. That was just equal to negative 6. Then you're going to take the magnitude of that. So the magnitude of u is going to be the square root of 3 squared plus negative 8 squared times the magnitude of v, which is just going to be negative 2 squared plus 0 squared. So you're going to have negative 6 divided by, so you're going to have 64 plus 9. That's going to give me square root of 73. And then the other one's just going to be square root of 4. So it's going to be negative 6 over 2 square root of 73. So right now, this is not the answer because we have the cosine of theta is equal to that. So now what you want to do is now you want to take cosine inverse. So theta is going to be equal to the cosine inverse of negative 6 2 square root of 73. So this is going to give me, so cosine inverse of negative 6 over 2 square root of 73. That's going to give me about 110.6 degrees. So basically what this is saying is that if I were to draw these two different vectors in space, the angle between the two vectors is going to be 110.6 degrees. That's basically what that's saying. So part D says, are the vectors orthogonal? So remember, what does orthogonal mean? Orthogonal means that the angle between them are 90 degrees. Clearly, the angle is 110, so they're not orthogonal. Okay. Alternatively, you can just look at the dot product. The dot product is not equal to 0, so they're not orthogonal. So we would say no vectors are not orthogonal because angle is not 90 degrees. Okay, and you can also say alternatively, I don't know how to spell it. Alternatively, I don't know. Alternatively, the dot product is not 0. Okay, so you could have also just said that as well. So you can say the dot product is not 0, therefore they're not orthogonal, or you can say that the angle itself is just 110.6 degrees, which is basically not it's not 90 degrees. Okay, so in the next video, we're going to do a couple of vector application problems of where you can actually apply all of these different ideas.